the alternating series. Let me write this thingy for you first. Harmonic series, P series with n is equal to 1, right? This thingy, of course, is 1 plus 1/2 plus 1/3 plus 1/4 and dot, 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 dot. And we have done this before. This is divergence series, correct? Say yes, not, to give me indication that you know what I'm talking about. Okay then. Let me make a little tweak to that series. So it's otherwise same, but let me put this little thingy here. Do you see that the signs alternate? And I'm gonna tweak it a little more so that purely for cosmetic purpose, so we can start with a positive number, you don't have to. So what we have is 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 and dot, dot, dot. And the question of the day is, would that converge or diverge? Knowing this one diverges, right? So what do you say? Is there a way to find out? We can do numerical analysis because we have a program that does these things for you, right? Yeah, let's take that machine out and we'll find out. Are you ready? We have to make slight modification to our program, and that is this. Okay. Take a look at this A, right? This is my A sequence inside. So the way we set it up is that we only need to modify that A, right? So copy what I have down here, okay? I have put that -1 to the n+1 power and make sure there's a parenthesis here. So that entire n+1 becomes the exponent. You have to be very good with a parenthesis, and there's a parenthesis here. And then divide by n to the p power and delete that +1 we had from yesterday. Okay, I'll give you a minute to update your program. Right there? No? Give a few more seconds. Okay. Oh, by the way, if you're behind in the notes, what do? Screenshot, right? Screenshot and dump it into your OneNote. Right, I actually have a video, so it doesn't matter. You can take a screenshot of the video later. Okay, trusting you're done. We'll test it. So program execute series, right? I mean, we always have to do beta testing, so p is equal to 1, and let's run it for 3 terms, okay? Okay, let's see. Number 1, that's this one, so good. Number 2, the first 2, this one plus that one, that's good. Those 3, let's just check that one, 0.5 plus 1/3, eh? Yep, that's correct as well. So program is working properly. And then we just run it. Should we run it for 10? Let's see what happens. What am I doing? What am I doing? Delete, delete, delete. Just press enter. Then this is 1. And then run it for 10 terms. Do you see that numbers kind of fluctuate back and forth, back and forth, back and forth? Okay, well, let's do it one more time. 100 this time. It doesn't take that long. Numbers are fluctuating, but that fluctuation gap is kind of decreasing. Do you see it on the screen? They are stabilizing, right? We're almost done. See that number, see, is 0.69-ish is where this thing went. So this is definitely converging series now, isn't it? Yep. See how great numerical analysis is? Excellent career. all of you should definitely look into it to see the applied math is a great field. They pay a lot more than pure math. Trust me, I know. Okay. So we have a big reason to believe that this will be 0.69-ish from our program. This is approximately 0.69-ish. You know what I'm saying? Okay, why? We have to find a way to justify why that's the case, and here's a graphic argument. This is not a proof, but hey, it'll do the job. It'll convince you. So suppose there's a case, say this is 1 right here, okay? And this is 1/2. And we are plotting SN, SK, okay? So this is SN, SK, let's put K. K seems to be our favorite index versus our K. You know what I'm saying? So at 1, we just take the first term, so our sequence gets plotted right there, doesn't it? At 2, your sequence, some of you actually have the program ready and spit out these numbers, like run first, let's say 5, 6 terms, then tell me what it is. So this was right here, isn't it? Which is coming down by half. And then we have to add third. So at 3, was it 0.8 something? Somebody tell me?
2.3.
And at 4, what is it? It's supposed to be about here. Now, how did I know? The thing is about the movement. See, the first term was up by 1, right? Second is coming down by 1/2. You know what I'm saying? From that previous position. Third term is going up by 1/3. And now we came down by 1/4. You know what I'm saying? So next one right here, we go up by 1/5. Each time there's a movement. Did I put it in the blue dot? I don't know why I did that. Each time there's a movement, it moves up and down because of the alternating signs. But you see it'll stabilize somewhere here, which happens to be 0.7-ish. You get the idea? Why this thing has to be convergent? Of course, it's not always convergent. If you make this thing grow like n to the -1 power, then it's like 1 -2 +3 -4, then it'll go and get out of control. That's definitely divergent series, okay? So it has to be decreasing down to 0 is the criteria now, isn't it? Oh, I have a question about this. Somebody asked me this during 5th period. What about this then? I'm going to put it with different color. -1. What is that thing? Actually, just to give a variety, I'm going to start this from 0 and then erase that +1. It still starts from positive. Is that convergent or divergent? What do you say?
Convergent.
This is convergent because if you pair this up and this up and this up and then they all add to 0, you're adding 0. Oh yeah? Okay, what happens if I pair this up and pair the next two up? Then I have 1, right? Which way is it? You, right? Shall we do graphical analysis just like this one? Yeah, let's do that. Actually, why did I'm going to clean it up later. So say this thing here. If I plot that thing, it's going to look like this. Let's say this is 1. So add 1 is here, right? Add 2 is here, right? 1 minus 1. Now we add 1, we're here. And at 4, we're down here again. So this seems to be the pattern, correct? This is oscillating. So this thingy, if I have to write it as SK is this 1 if K is odd, and 0 if K is even. Isn't it? And the question is that convergence? Because it's not infinity. What do you say? I mean, it's clearly this, right? 1, 0, 1, 0, 1, 0. It's either 1 or 0, but it ain't infinity. So should we call that convergence series? It all depends on what the definition of convergence or divergence is. Let me give you, just for the humor, give definition of divergence first. Definition of divergence is not infinity. Do you know what the definition of divergence is? Anything that is not convergent is defined as divergent. Well, then the natural question is, what is the definition of convergence then? Isn't it? Definition of convergence is you have to, your limit has to be one finite number, 1. In this case, we have 2 finite numbers, right? So oscillation is divergent by definition. You have to get only 1. So in this example, see, it's oscillating, but that gap of oscillating is diminishing, right? So eventually you converge to, you zoom into 1 number. In this case, that gap never closes, so it's divergent. You get it? Actually, infinity or negative infinity, I forget. I think they are called the proper divergence or something. I mean, people create the analyst will create the definitions for those two, but divergence have many, many, many different things, right? So it's like just if it's not one finite number, it's divergent. That's how you want to remember it at this level. Good. With that, let me give you the criteria of alternating series. So alternating series, the way we define the sequence Bn is without the alternating sign. Okay, so when I say Bn, this is going to take care of your alternating sign. And the Bn in this case means just 1, 1/2 the harmonic series. Get it? Those are Bn's. Otherwise, we lose sanity on, is it negative, positive? So this is all positive series. So number 1, oh yeah, that's nice, right? This sequence must die. That's what gives you this closing gap. If it doesn't, then we have this kind of divergence. You know what I'm saying? In fact, this is the criteria of the convergence of all series. Whatever you're adding, since there are infinitely many terms, they better die. That makes sense to you? Otherwise, you're adding finite number, no matter how small it is, throughout eternity, and that's gotta give you infinity. But then, is converse always true? Because after disclosing this information, I get this on the test all the time. So find out the convergence of this series, right? And then many students say, oh, the limit of that sequence inside is 0, therefore it's convergent. No, no, no. In logic, converse is not necessarily true. And that counterexample is right there. This thing, if you take a limit of 1/n, that is 0, but yet this is divergent. You get it? So if the limit of the sequence inside is 0, then we have a fighting chance. This may or may not converge. You know what I'm saying? Not only this has to die, but for the series to converge, this has to die really, really fast. Okay? But in case of alternating series, it doesn't have to die as fast. As long as it dies, then it's good enough. Because of this alternating sign, it's not going to increase. You know what I'm saying? It's just, it cancels each other and go up, oscillate up and down. So as long as that gap gets closed, then we're fine. Are we good? Okay, so that's great. The second one is a little weird. I mean, I had to struggle. Why do we, this means it has to be strictly decreasing sequence. Every term after has to be smaller than before in its magnitude. But why? Doesn't this include this? What do you say? If the limit is zero, sequence is dying out to zero, then why do we need this set, right? That's a good question now, isn't it? I've been struggling with this for some time. Then this is already years ago. So I ended up contacting this math professor from Stanford again. It's a different one than that limit speed, the limit from chapter 8 approaching, yeah, that guy, right? So no. This time it was a nice lady. So I asked her, you know, why do we need this? And then we had to go back and forth because first she didn't really understand my question. So we've been exchanging email like several times now. And then there's a story to go with it, but I don't want that story to be in the recording. So when I stop the recording, I will tell you the full context of that story. It's a funny story, but I got the answer back. And this is the answer. So the question is, why do we need this? Why we need this thingy? This is a difficult thing to prove, right? And she gave me this example. This is according to Stanford professor. Once again, this is how mathematicians think. So AN, and then she will define AN like this. It's kind of similar to this thingy up here, okay? We'll put 1 over n if n is odd, and then we'll put negative 1 over 2n, so the signs alternate if n is even. Let's write down this series. So this thingy then will be 1 minus 1 over 2 to the first square, right? 1/4, plus 1/3 minus 1 over 2 to the 4th power plus 1/5 minus 1 over 2 to the 6th power, and dot dot dot. Do you see it's not strictly decreasing, right? This term is smaller than this one, is bigger than that, right? So what ends up happening is this geometric series, so even term is geometric series with negatives, odd term is harmonic series. These geometric series die out so fast, eventually this thing will be almost like just harmonic series, and that will diverge on you. I mean, you can write a program, if then statement, and do it that way, but this will be divergent. Dang, right? Wow. Who the hell thinks like that? This is what mathematicians worry about. I was surprised, like, dang, who comes? I mean, this is almost as surprising as the speed of the limit approaching that vertical asymptote thing, wasn't it? Yeah, pure math people. Okay, for this kind of counterexample, because if we only need to prove this, that's great. Life is hallelujah, right? But no, we have the second headache to prove. Oh, okay. Any questions so far before I give you a concrete example? Because here's a example. Okay. Okay. So I'm gonna do this first. So find the sum of the, actually I'm gonna do this one first. This one makes a little more sense, okay? What do you say by looking at it? Is it convergent or is it divergent? Can we put this thing into sigma notation? Oh, let's sharpen, let's review our sigma notation skills. That thing is, first, we need something like this, right? And then what do you put and what is the indexing? That worked for you? And in the denominator, what do you want to put? It sure looks this way now, doesn't it? And let's check the sign. When n is equal to 1, we start with a negative. So that's even that worked out. I usually do this last. If I want it to start from different sign, then I put +1 or -1. You get it? Okay, this is it. Well, then, first thing I want to do is this, that Bn, this is Bn, right? I want to take this limit as n approaching infinity. And that is 1 now, isn't it? What does that tell you? What that tells you is these things eventually, long time later, will be -1, +1, -1, +1. It'll follow that pattern. You know what I'm saying? And we already talked about this. This is a divergence oscillation, isn't it? So graphically, it starts from negative, but whatever, right? It does this. It closes the gap, but after a while, this gap never closes. It just keeps the same oscillation. It eventually ends up being that thing. And so this will mimic oscillating series towards the end. So this is divergent. You get it? See, all series, this is the only thing you look at. If any series fails this test, then it's divergent right there. Good. Okay, so there's that. Okay, let's do the second test then. Let's write this into sigma notation. How should we do this? Well, we have this thingy, okay, over ln. Why don't we just do ln n? And then all I have to do is start from number 2 to infinity. How about that? And then let's check the sign. If n is equal to 2, first term starts from positive. So that did it. Good. So now let's show well, let's just, by looking at it, let's see. Alternating series is this easy. If let's say this is a multiple choice, you take a limit of that thingy. This is the only thing you need to see. Limit of your Bn, which is this. And that's 0, isn't it? And then you don't do the second one, you just say it's convergent and move on. You get it? If you just need to know this answer quickly, that'll do. We never have to, at high school level, that Stanford professor, we never have to worry about this example, okay? I've never seen it. I mean, I had to ask that professor about this. So if I have never seen it, and I got a degree in math, you would never see it. Unless you go into pure math and go for a PhD program, then maybe you have to worry about this. But other than that, right? So it'll never happen. So this is it. We know it's convergent by looking at it. But just to satisfy the anal mathematician, we have to do this part. We need to make sure this is true, okay? And number 1, 2-column check. No, that doesn't fly, but this is good. This means if and only if going sideways, right? So I'm gonna put my sequence. Is this true? Is the question. Well, if you're not sure, that's true if and only if. Without these, if and only if this is not equal sign, if you don't put it, I'm going to take a point to remind you. Cross multiply. So this is ln n. Is that true for n? Well, if you're not still sure, that's the same thing as this, right? Oh, that's definitely true, right? I mean, it's a judgment call. How far do you want to go down? We can go forever. Subtract n from both sides. Oh, now this is true. I mean, we cannot go any further. This is true. Good. You don't have to put this is true statement, but I like to put it because our series starts from number 2. You get it? So this is known as the alternating series test. Good. So we can conclude here, therefore, so series is convergent. By alternating series test. How about that? Good. Say yes. Can you do this part? This is more headache. Some people would like to do with a derivative. You just take a derivative of that thing, EBN, and if it's always negative, then that also proves the same idea. But you have to show that this is strictly, every term must be getting smaller. Are we good now? Okay, then let's look at the error estimation. Okay, this alternating series error is one of the favorite problems from AP. Alternating series error is just the very next term. Like, why would that be? Let's go back to the graphics and figure it out, right? Say I use the first 2 terms to estimate the series, right? Which is 0.5. In reality, it is 0.69, but let's say 0.5, right? If that being the case, then I'm just trying to estimate the rest of the error, which is starting with, when you say R2, that starts with the 3rd term, correct? See, rest of them will never be bigger than 1/3 because they just keep oscillating and get smaller and smaller. If I use these 3 to estimate, so let's say that's S3, then my error will be less than 1/4 because we have no good way to add up these error forever. You know what I'm saying? So the alternating series error is always just the very next term. How about that? This is the easiest error, but this is AP's favorite for some reason. You've seen it many times. With that, we'll do this example. Okay, now let's say sum of the correct to the 3 decimal places. How do we do this? Well, we first have to find the error analysis, right? Okay, let's do that. So our error is this, R of n, and we don't know what n is because we are trying to figure out how many, right? That needs to be less than or equal to, well, n plus 1, the very next term in the sequence. Get it? 1 over n, so the next term. You know what I'm saying? Phi this be n plus 1 term without the negative sign. Who's confused? Show hands if you're confused or if you want me to elaborate. Okay, and we want this thing to be now less than, when you say correct to 3 decimal places, I'm not sure how to, I think this is it. Oh yeah, there. 0, 0, 0. I never understand. Yeah, 3 decimal should be 0, right? Okay. And there's no good way to do this except with a calculator, right? So somebody to punch the calculator and tell me what that n should be. This means n should be greater than, come on, flip it over, subtract 1. Useless kids. Too much algebra? With a calculator? Okay, so we have to run this thing for 1,111 times in order to achieve this error. How are you gonna do that? Well, like this, of course, right? So we just run this one more time. This is our very example. So 1, and then your K, 1, 1, 1, 1, and then have this thing go. And let this thing cook for a while. Wait, let me see if I can speed this thing up. Maximum. It's gonna skip numbers. Okay. We'll let this thing cook in the background and I will give you the answer. So now S1111 should be 0.693597. See, it'll converge around at 0.69-ish. Let's see if this thing is done. Well, still going, but it's halfway. I'm gonna put it on this side. Okay, do we have any questions? Okay, I'm going to stop the video. Now it's almost done, so I'll wait for this to end, then stop the video, then finish the story. Okay, you get it? 0.693597. Good.